Hello everyone, welcome to the lecture on Clausius-Mossotti relationship. So this relationship is about the relation between dielectric constant of the material and the atoms present and the polarizability of the atoms present in the material. So dipole moment of a single atom, it is directly proportional to the local field. So here dipole moment, uh, it is nothing but dipole moment arises when there is a separation of charges. It can be a single atom. The single atom can be charge neutral, but if there are charges in the atom and they are separated by a distance r, then that causes dipole moment. And that dipole moment of a single atom, it is proportional to the local field experienced by the atom. So here local field is nothing but the resultant of both internal and external field. The external field is the field that we apply with the voltage source or any source that is giving electric field, that is giving external electric field. Along with that, there is internal electric field which comes because of dipole moment. So here the dipole moment of single atom, it will be proportional to the local field, and that dipole moment is represented by mu e and local field is represented by el. Both are proportional, and when we remove the proportionality constant, we get mu e is equal to alpha times el. Here alpha is the polarizability of the atom. So here the polarizability of the atom is nothing but how much uh, how much separation of charge carriers, means in an atom we know that there are charges like electrons. So when we apply electric field, how much separation we can cause between the charge carriers. So that is a polarization. So it is the tendency of the charge distribution, that is like an electric cloud in an atom, to be distorted from its normal shape. So before applying the electric field versus after applying the electric field, what will be the distortion uh, in the charge distribution that represents the polarizability of the atom. Now let's say that number of atoms per unit of volume in the material is n. Now the polarization is nothing but the polarizability of the atom is different and polarization is different. The polarization is dipole moment for unit volume. We know dipole moment for a single atom, that is alpha times El. So polarization will be uh, n times alpha El, because it is dipole moment for unit volume. So this is the first equation that we take here. P is equal to n alpha times El. Now polarization P is related to applied field and electric permittivity. So here this polarization, the applied field is E. Applied field is represented by E and local field is represented by El. So we can see the relation here. P is equal to epsilon naught E into epsilon naught R minus 1. Here epsilon naught R is the electric permittivity and P is the polarization. So both are related in this way. And this is P is also equal to N alpha times El. So that became second equation. Now from 1 and 2, when we equate both, we get electric permittivity. So by simplifying the terms and getting electric permittivity epsilon naught R, we get this equation. And so here we want to separate El by E. El is the local field and E is the applied field or external field, you can say. Now when we find El by E, we get by rearranging the terms, that is by taking one this side and multiplying with epsilon naught and then dividing by n alpha, we get third equation. So here local field El, it is related to polarization P as well as applied electric field. So local field is nothing but it is the resultant of internal electric field as well as applied electric field. And we know that internal electric field is related to polarization P. So in that way, local field El, it is equal to E is the applied electric field and P by 3 epsilon naught. This is the polarization P is the polarization by 3 epsilon naught. So then calculating the applied field EL, which is EL minus P by 3 epsilon naught, and we know the value of P, that is N alpha times EL polarization. So now we got, so actually here the local field and applied field both are related by polarizability. See, N is the constant, that is number of atoms per unit volume is constant once we take in the material, and we know that electric permittivity of free space epsilon naught is a constant. So here the only things that are variables are applied field, local field, and alpha. So the applied field, so the local field is related to EL by E we have here. If we take E here, the local field is depending on, one is applied field. Suppose if we take E to numerator side, then EL is depending on the applied field E, and the other thing that is depending is alpha, that is polarizability of the atom. So here, based on this, we can say that local field is depending on applied field as well as internal electric field. The internal electric field is corresponding to the polarizability alpha. Now from 3 and 4, when we equate both of them, as the both terms are equal, we get epsilon naught r minus 1. So here just mathematical calculations and getting epsilon naught r, that is by taking minus 1 to this side, plus 1, and then adding the terms and so forth until we get epsilon naught r. So once we get epsilon naught r, that is electric permittivity of the material, uh, we can we can do one thing here, that is we can write 2n alpha by 3 as n alpha by n alpha by 3, but we are also multiplying here numerator and denominator with epsilon naught. So here epsilon naught cancel, so that will yield n alpha minus n alpha by 3 is 2n alpha by 3, and we put this epsilon naught as it is, and in the denominator also we are multiplying and dividing with epsilon naught. Now we get epsilon naught r, that is equal to n alpha plus, here we are taking epsilon naught common, here also we are taking epsilon naught common. Now we have this equation. So next what we are doing is we are dividing numerator and denominator by epsilon naught. So when we do that, we get n alpha by epsilon naught, and here plus 1 minus n alpha by 3 epsilon naught as it is, and here also this epsilon naught cancel, that will give 1 minus n alpha by 3 epsilon naught. Then we find epsilon naught or here 1 n alpha by epsilon naught minus n alpha by 3 epsilon naught, that will give 2 n alpha by 3 epsilon naught by 1 minus n alpha 3 epsilon naught. So this is how we calculate epsilon naught r, and then we calculate epsilon naught r minus 1. When we subtract minus 1 and simplify and calculate, we get n alpha by epsilon naught by 3 epsilon naught minus n alpha by 3 epsilon naught. Then it yields this equation 3n alpha by 3 epsilon naught minus n alpha. So this is the fifth equation. Here we find epsilon naught r minus 1, where epsilon naught r is the electric permittivity of the material, and you know the n is the number of atoms per unit volume, alpha is the polarizability. Now here when we see, we can also calculate epsilon naught r plus 2, that is adding plus 2 to this epsilon naught r term, that will result us this equation when we do the calculations. So it's just simple maths here. Then when we divide this epsilon naught r minus 1 by epsilon naught r plus 2, we get n alpha by 3 epsilon naught. So this is the Clausius-Mossotti relationship. So in the Clausius-Mossotti relationship, you can see that dielectric constant epsilon r, that is related to polarizability of atoms. So here n is the number of atoms per unit volume, which is constant once we take the material, and epsilon naught is also constant, that is permittivity of free space. So now here the only variables are epsilon naught r and alpha. So Clausius-Mossotti relationship determines the relationship between these two parameters. So if the polarizability of the atom is high, then the electric permittivity or dielectric constant of the material will be high. So here basically what is the definition of dielectric constant? It is nothing but how much how with what high magnitude does the charges distort in a material when we apply electric field. So that is how it is related to polarizability of the atom. Now we can also put this relation in another way, that is when we multiply with uh, Ma by rho. Here Ma is the molecular weight and rho is the density of material. So basically Ma by rho is the molar volume. When we multiply Ma by rho on both sides, then we have N Ma by rho. This is Avogadro number. So basically the molar volume is nothing but, uh, sorry, the number of atoms present in a material, in the number of atoms per unit volume is nothing but Avogadro number by molar volume. So that will give the molar polarization, which is equal to Na times alpha by 3 epsilon naught. Alpha is the electronic polarizability or polarizability. So this is how we got Clausius-Mossotti relationship. Thanks for watching this video and please subscribe my channel to get more videos.